The knapsack problem. The knapsack problem is a problem in combinatorial optimization. Given a set of objects or items, each associated with a profit or a value and a weight, determine the total number of items in a collection so that the total weight is less than or equal a given limit and the total value as large as possible. This is in simple words. The objective, we have number of items or objects, 1, 2, 3, 4, 4 items, and a given total weight, a condition or constraint. The objective, maximize the profit, which is subject to this condition. The total weight that has been collected is less than or equal to m, which is 6. In this example, is 6. So, to understand the idea, we want to collect items taken into the account, the weight item, to be less than or equal 6, such that the profit is maximized. It's a maximization problem, so it is optimization problem. It's a combinatorial optimization problem actually. So the greedy method can be incorporated here. Let's see. First approach, we can start taking the less weighted items first so that we can fit as much as we can of those items to meet the condition, the limit of the weight. So let's start and see the difference. We have 3 approaches. First one, to choose the least one. Second approach, start with the items that has maximum profit. Keep add them to the collection until you meet the weight. The final approach, which is the one that we will prove is the feasible one or the optimal one, is to take the ratio profit by weight, okay? Which, because of the time constraint, I calculated it. So this is nothing but 4 divided by 1, 4, 10 divided by 3, 3.3, 15 divided by 5, and so on. So this is the ratio. So let's start with the first one. If we take into account the profit. So the object, which one with the biggest profit? This one, 15. 15 is object number 3. So object number 3 with the profit 15. What is the weight? 5. So what is the remaining weight? We have 6 minus total weight, 6 minus 5. We left with only 1, let's say kilogram. So what is the next highest profit? This one, object number 2. What is the profit of object number 2? Is 10, okay? But what is the weight of object number 2? The weight is 3. But we left with only 1 weight unit. So we have to take 1 out of this 3. So this profit, we will multiply by 1 divided by 3. So we're gonna take 1 out of this 3 units of weight. Okay? So this will be 3.33. So here, since we take only 1 unit, so we have 1 minus 1. So no weight left. So if we calculate this, 15 plus 3.3, it's the first one with the profit, it will be 18.33. Okay, let's see the objects with less weight, not with the highest profit. So which one is the first? The first weight is this one, object number 1. What is the profit? 4. What is the weight? 1. So what's the remaining weight? 6 minus 1, which equals 5. Now, what's the next least weight? This one, 3. Object number 2 is the profit is 10. The weight is 3. So 5 minus 3, which is 2. We still have some space. What's the next? 4. This one, the weight is 4. So the number of object is 4. The profit is 9. But since the weight is 4, we are left only with 2 units. This problem called fractional knapsack problem. In this case, we can take a fraction of the total weight. There is another method called 0, 1 knapsack. In such case, we cannot take a fraction of the weight because you have to take it all together, either in 1 or 0. Okay? Let's see. In this case, we're gonna take only 2 units. So 2 units out of 4, so 2 out of 4 from the 9. So this is half of the 9. What's the half? Is 4.5. Okay? So if we calculate now, we took 2 minus 2, we have no more space. Okay? From 6, we left with no space. So now, let's calculate this. 4, 14, or 50, so it's 18.5. This is the second one. Let's now calculate the profit to this problem using the maximum ratio between profit by the weight. So we calculated it. Take the max first. So the first one is 4. 4 is bigger than 3 and 3.3 on 3 and 2.25. Object number 1, the weight, the profit is 4. Okay, the weight is 1. So we have 6 minus 1 equals 5. Next one, 3.3. Okay, object number 2, the profit is 10. The weight is 3. So here, 5 minus 3, we left with 2. But now we go to the next highest, which is 3. This is the third ratio. 4, 3.3, 3. So what is this? This is object number 3. The profit is 15. And the weight is 5. But we have only 2 here. So we're gonna take the ratio out of the profit. We're gonna take 2 out of the 5. So 5 by 5, this is 3. 3 multiplied by 2 is 6. So we have 10 plus 4 plus 6, it's 20. Hey, we see here, the best way to choose the correct optimal solution out of those feasible solutions is with the ratio. And that's how greedy method works in this specific problem, which called knapsack problem. I hope you understand everything, and thank you.